this question, a function fx satisfies the following two conditions. f1 equals to 2046 and the summation of f1 to fn for a positive integer n equals to n squared times fn. If that's the case, what will be the value of f11? Now, using the second condition, we can actually have f1, f2, all the way to f of n minus 1. It will be equals to n minus 1 square f of n minus 1. Now, call this is equation 1, equation 2, and equation 3. So we can take the equation 2 minus equation 3. Then we'll see that this is f1, f2, f3 until fn minus 1, and you will cancel with the left hand side of equation 3 and we left with fn. And for the right hand side, it will be n square fn minus n minus 1 square f of n minus 1. So this means that n minus 1 square f of n minus 1 equals to n square minus 1 fn. Now notice that this can be written as n plus 1 n minus 1 f of n. So this means that f of n will equal to, after cancel the factor n minus 1, it will be n minus 1 over n plus 1 f of n minus 1. With this, then we can see that in order to get f11, so f11, it will equals to 10 over 12 of f10. And this will equals to 10 over 12, 9 over 11 of f9. And we will proceed on, and you will see that this will be 10 over 12, 9 over 11, all the 8 over 10, all the way to 1 over 3 of f of 1. And this eventually means that 10 will cancel with 10, 9 cancel with 9, 8 cancel with 8, until 3 cancel with the 3. So what we have is 2 times 1 and 10 times 11 of f1, that is 2046. So with this, f of 11 is equal to 2046 over 66. And after calculation, this will be equal to 31. And therefore, f of 11 is equal to 31. And in the middle, actually you're using the idea of telescoping of the product. So this is the end of today's lesson. I'll see you again. Bye bye.